So there was this thing that I said, and I didn't quite justify it straight away. But let's try and justify it. So I had this was the important thing. The probability of extinction, let's say, by generation n was equal to g of the probability of extinction by generation n minus 1. And that was a big part of my proof, and that final thing I showed you for ultimate extinction. I need to justify that, really. So if you imagine I was rolling one of my die, it might look like this, kind of like 4 scenarios, just for the first generation, for the first roll. I could have 0 kids, 1 kid, I could have 2 kids, or I could have 3 kids. Right. Other examples, you could carry on with 4 and 5 kids. Now, the important thing to notice here is that each branch returns us to square one. The whole process starts again for each branch. So in this example here, I've got 3 branches, and then the whole process starts again from 1. So we're kind of 1 generation closer now to this idea of extinction. So let's break down the probability of extinction into these 4 cases. Probability of extinction by generation n. Well, what could happen? I could have 0 kids, which means I've gone extinct already. If I use the values that I had on my die, that was a probability of 1/6. Okay, what else could happen? Well, and that means I'm going to add the next probability, I could have 1 kid. The probability of that was 2 out of 6. So I've had 1 kid, and now I'm interested in the probability of going extinct, but I'm 1 generation closer. So I've had 1 kid, let's put that probability in, 2 out of 6. And now, if I want to know the probability of going extinct by generation n, I now want to know the probability of going extinct by generation n minus 1, because I'm 1 generation closer. Well, let's do the next example. I could have had 2 kids. Right, well, the probability of having 2 kids was 2 out of 6. Now, I've got 2 branches. I want to know the probability of this branch going extinct by generation n, and this branch going extinct by generation n. So, well, the probability this is going to go extinct by generation n is now probability of extinction by generation n minus 1, because I'm slightly closer. And again, it happens again, so that gets squared. So it happens again and then again. So that gets squared. Last example, kind of the same. Probability of having 3 kids was 1 out of 6. And now I want each branch to go extinct. If each branch goes extinct, that's the extinction by generation n minus 1. Because I've started the whole process again, but I'm 1 generation closer. But for each branch, so that's cubed. Well, this formula is exactly the same formula I had for G. But instead of X, it's not X, it's the probability of extinction by generation n minus 1, which is what I was trying to show. So you break this down. We looked at the first generation and then what happens next. And what happens next is 1 generation closer to the generation n, which is what we were interested in. So this process is called the Goten-Watson process, and to be honest, it's not really a good way of modelling the extinction of family names, because there are lots of ways that a family name can change. There's loads of reasons why people change their family names, but there are things that it can be applied to. So it can be applied to the spread of diseases. It can be applied to when there's some kind of chain reaction. And it can be applied to when there is something that gets passed down from father to son. For example, the Y chromosome. So maybe you'd be interested in when a certain type of Y chromosome is going to go extinct in the future, which is something that is passed down from father to son, we could use this process. In the same way, we could study something that we get from our mothers. An example of that is mitochondrial DNA, which is something that we all have. We all have this mitochondrial DNA. It makes our cells work. But we only get it from our mothers. We actually get it in the womb. So we can only get it from our mothers, who got it from their mothers, who got it from their mothers in turn. And we can then actually trace back that lineage back through our mothers. And if we all do that, we actually all reach one woman. This one woman is called Mitochondrial Eve, who we are all descended from. We all share her DNA. She lived 200,000 years ago somewhere in Africa. Her name is kind of misleading, Mitochondrial Eve. She wasn't the first woman. She wasn't the only woman at the time. So there were other women at the time. And they're all passing down this DNA. They're all passing it down to their descendants, but all their DNA has gone extinct. And so this Mitochondrial Eve is the woman whose DNA has survived to the present day. And she is the most recent ancestor who we are all related to through our mothers.
24 possibilities. The top card can be any of 4 cards. The next can be any of 3. That's 4 times 3 is 12. Times 2 is 24. And then this is forced to go left. So you could just do it 1,000 times